Introducing concave lenses by KayScience.com. This here is the axis. It's a line that runs through the center of the lens and it's perpendicular to the lens. What I'm drawing here is a concave lens. It's a concave lens because it caves in on either side. It's not a convex lens like the one shown here, which bulges out on either side. This is an incident ray that is traveling parallel to the axis. When the incident ray reaches the concave lens, the light will refract and bend away from the axis, so the light ray diverges. So it diverges away from the axis. And as you can see here, the dot that I just put is the principal focus, and that's the near side principal focus. This is another incident ray that is traveling parallel to the axis. And when it gets to the concave lens, the light refracts away from the axis and diverges. The light ray doesn't converge like in a convex lens, it diverges. So any incident ray that travels parallel to the axis is going to diverge away from the axis after it refracts through a concave lens. So where is the principal focus for a concave lens? So the principal focus of a concave lens is the point where rays hitting the lens parallel to the axis appear to have all come from. So as you can see here, if you trace the refracted ray back to the axis, it's going to meet at the principal focus. So what I'm drawing here are virtual rays. This here is a virtual ray that traces back to meet on the axis, which is the principal focus on the near side of the lens. So all of these virtual rays meet at the principal focus on the near side of a concave lens. So this point is the principal focus. And remember that the focal length is the distance between the center of the lens and the principal focus. So this here is the focal length. And the virtual rays all meet at the principal focus on the near side of the concave lens. It's question time. Attempt these questions to check your understanding. So what are the 3 rules for drawing rays passing through a concave lens? So this here is the axis. This is a concave lens. And now we're going to draw a light ray, which is an incident ray traveling parallel to the axis towards the concave lens. So as you can see here, the refracted ray refracts away from the axis. And if you draw a line from the refracted ray back towards the axis on the near side of the concave lens, that line is going to pass through the principal focus. Principal focus. So the rays on the far side of the concave lens appear to have come from the principal focus on the near side of the lens. This ray refracts, and it now refracts so that the refracted ray is now traveling parallel to the axis. So as you can see here, the light approaches the concave lens and it refracts and diverges, so it's now parallel to the axis. So if we draw a virtual ray tracing the near side incident ray, then the virtual ray is going to pass through the far side principal focus. So this dot here represents the principal focus on the far side. The principal focus on the far side. And just like on a convex lens, light rays traveling through the center of the concave lens is going to continue on in a straight direction without bending. It's question time. Attempt these questions to check your understanding. Press pause to practice using those key words. The answers will follow. Press pause to go through your answers and make any corrections to your mistakes. Press pause to answer the questions. The answers will follow. And if you're stuck, just re-watch the video. Press pause to go through your answers and make any corrections to your mistakes.